Oh, excuse me. I'm expecting company. I'm expecting an old high school friend to come by into my home, and so I'm interrupting this video just for a second and invite her. Come on in, Elizabeth.
What a dump.
Oh, I guess it is. Well, sorry. I don't live in the best place. I can't help it. And my dog is barking at me too. Find and sketch the domain. Aha, find and sketch the domain of f and justify your answer. Well, here's our function. And whoops, I put the sketch there ahead of time. I didn't mean to do that. Here's our function, x over the square root of 16 minus x squared minus y squared. Well, things that come to mind. Can you divide by 0? The answer is no. So now let's get a little high tech on this. If we can't divide by 0, can we take the square root of a negative and still have a real valued function? The answer is no. So we're getting a little high tech here.
Open the pod bay doors, please, Hal.
Wow, that really did get high tech. So we have a denominator that can't be 0 and a radical that can't be negative, right? It can be, as a matter of fact, it can't be 0 either. So here's our issue. X squared plus y squared has to exceed 16. So x squared plus y squared equals 4 squared would be the equation of a circle of radius 4, but it can't be on the boundary, right? The domain can't be on the boundary. So therefore our picture is this circle where x squared plus y squared is less than 16, but not equal to 16, and showing that it can't be on the boundary. I hope you can see that I have a dotted line around there. So that was my intent. And here's another similar example. Find and sketch the domain of f. Again, justify your answer. Well, there's that pesky 16 minus x squared minus y squared under a radical again. So we know that we've got a problem. X squared plus y squared has to be less than 16. And so that actually less than or equal to 16. You know why it could be equal to 16 this time and it couldn't this time before? Well, here, if it was equal to 16, we'd have a denominator. Oh, I didn't mean to do that. We'd have a denominator 0, and we can't have that. But this one, its numerator equal to 0, and we can't have that, so that's not a problem. That means, if I look at my picture here, I'm now including the circle, and so therefore I don't have it drawn as a dotted line, but this is all divided by y, so that means y can't be 0. Well, y equals 0 is another name for the x-axis, and I guess I tried to draw a dotted line through here. It didn't look too dotted in this part, but trust me, it was supposed to be dotted there. And I'm trying to show that the x-axis, I'd have to throw the x-axis out of the domain of this. So the domain is all the points inside this circle except all the points on the border of the circle, except none of the points on this line right here. That's the domain of this function. That's sure more bizarre than usual you see in one variable calculus, where the domain is just some interval of the x-axis. So I hope you find that cool.